Here we've been given a geometric sequence, but we don't know where these terms fit. Okay, so we have Tn and Tn plus 1. So although we don't know where these terms fit, we know that Tn is 10 and the next term over is 15. Okay, so we don't, like I said, we don't know where these fit. So it could be anywhere in that sequence, but we know they're next to each other. If we know they're next to each other, we know that the common ratio r can be found by dividing those two terms. So the common ratio r works out to be 1.5. So we're being asked to solve for starting value a given S5. So I know that S5 is equal to a r to the n minus 1 over r minus 1. Okay, so if that's the case, then I can plug this into this equation. So 1055 over 18 is equal to a, which we're looking for. We know what, I'm just going to fix this here. So we know n is 5. We know r. R we've worked out to be 1.5 to the power 5 minus 1. And that's all going to be divided by the r value that we calculated, 1.5 minus 1. Okay, so solving this equation then, we end up with 1055 over 18. This a, I'm just going to work that out all as one coefficient. So 1.5 to the power 5 minus 1 and divided by 1 minus 1.5 minus 1, which is 0.5. And we end up with a is equal to, I'm just going to keep it as a decimal, 13.1875. Okay, so that's an exact decimal, so don't round it. So solving for a, I'm going to end up with 1055 divided by 18, and divide that by that number. So I end up with a is equal to 4 repeating, or 4 and 4/9. Okay, which as an improper fraction is 40 over 9. So there's our a value. We can solve this algebraically once we establish, first of all, the r value based on this property of consecutive terms, giving us the r, and then using the formula and solving for the unknown part in that formula. So here we have the Sn value. We don't know the n value though. We've been given the start value, which is the same as a. And so I know that Sn is equal to 93. And putting into the formula, I'm going to end up with 3 times 2 to the power n, which we don't know, all over 2 minus n. So 2 minus 1. So once I've put it into the formula, the only variable that I have is my n value. So I can just solve for that. So I get 93. The denominator is 1. So I end up with 3, 2n minus 1. I can solve this by dividing by 3. So I get 31 equals 2 to the power n minus 1. 2 to the power n equals 32. I can use a log to solve this, but I know that log base 2 of 32 is equal to n, which is 5. So n equals 5. Actually, I should write it equal to n, and then n is equal to 5. So there's our solution. For infinite geometric series, the formula is going to be S is equal to a over 1 minus r. Okay, we have the a value. We can calculate r by dividing consecutive terms. So the r value is equal to 0.4. So we have 100 divided by 1 minus 0.4. Really, we're just establishing R and plugging into the formula. So 100 divided by 0.6. I'm just going to leave that as 1,000 over 6. We could simplify this into 500 over 3.